In this video, we are going to find the solution to our circuit by using AC circuit theorems. The method used are Norton's theorem, mesh analysis, nodal analysis, and superposition theorem.
Okay, this is the simulation of our circuit. This is the value of the simulation. And this is the comparison between calculation and the multisim, and the value is quite same. Assalamualaikum warahmatullahi wabarakatuh. Today I want to present to you about the Norton's theorem. This is my original circuit. For the first step, just remove the impedance that we want to find the current and voltage. For this case, I remove this resistor or impedance, this. Okay, for the second step, calculate the impedance and by set also 0. For the current, I set 0 and it become the open circuit. For the voltage, when set to 0, it become the short circuit. Therefore, inductance and my capacitance. Firstly, for the Zn parallel this and series this. For the total parallel and series, parallel with the 4 ohm resistor, and it is my value for Zn. For step 3, just short the terminal A and B and find In. I use the mesh analysis. I make a for loop for this circuit. For the mesh analysis, I use the KVL, Kirchhoff voltage law. Take the voltage plus with the inductance. I1 multiply with inductance, and I1 minus with I3 multiply with the 8 ohm resistor. And this is for the my equation 1. For the second equation, just take the current because it gives the current, and the third equation and the fourth equation same like the loop 1. After it, just sub the equation 2 to the equation 3. This is the equation, and use the primer rule for the first equation and the third equation, and find the determinant. This is the determinant. After that, find the determinant of I3. Just change the value with it. This value go to this value and find the determinant I3. This is the value of the I3. After it, find the I3 by divide determinant I3 with the determinant. This is the value. And find the In by divide the I3 with the I4. This is I4. Okay, and we get the value of In. The last step, draw the Norton equivalent circuit. This is the Norton equivalent circuit. The N that we got just now. The In we got just now. After that, use the current divider rule to get the I0 or I across this resistor I4, and we can get the value. This is the to get the I0 or current across the I4. Just Zn, the value Zn, divide the value of Zn plus with the 2 ohm resistor and multiply with the In, and we can get the I0 or current across the resistor 4. For the V0 or voltage at this resistor at the voltage at the R4, just multiply the I0 or current across the I4 with the 2 ohm resistor, and we can get the V0 or VR4.
I am going to show you how to find the value of current and voltage at R4 by using mesh analysis. This is the circuit. First thing that you need to do is to find XL and XC and change sine to cosine so that it is in the same phase as the other sources in the circuit. Next, label each loop as L1, L2, L3 and L4, and then find the equation for each loop by using KVL. So this is the equation for loop 1 and loop 2, and this is the equation for loop 3 and loop 4. Next, derive the equation so that only I3 and I4 are in the equation. After that, find I3 and I4 by using Cramer's rule. After obtaining I3 and I4, we can easily find the value of current and voltage that we are looking for, and the answer that we obtain here is the same as the result of the simulation in multisim.
So this is the method that we are going to use, which is nodal analysis. This is our group circuit design. First, we need to assign node V1, V2 and V3 at each of the node. Then, first thing first, we need to change inductance and capacitance into impedance unit and convert voltage source V1 from sine to cosine form and voltage source V2 into positive amplitude. Then, in order to calculate, apply KCL at each of the node, and we will get equation 1 from node 1, equation 2 from node 2, and equation 3 from node 3. Then find determinant by using Cramer's rules. As we need to find V3, find determinant V3 by using Cramer's rules too. And in order to find V3, divide determinant V3 by the value of the determinant that we got just now, and we will get V3. After we got V3, find the I node by using Ohm's law, which is V3 over R4, and we will get the value of I node. So, thank you.
Assalamualaikum. So today I would like to show how to find voltage drop and current across a resistor by using one of AC circuit theorem method, which is superposition. So basically, this is the original circuit that have been constructed. There are two voltage sources, one current source, one inductor, one capacitor, and 5 resistors. So we are going to find voltage drop and current across the resistor number 4. In order to find the voltage drop and current across the resistor number 4, firstly, we have to simplify the circuit by remake V source and set current source equal to 0. So, because there are more than one sources in this circuit, we are going to use mesh analysis by using Kirchhoff voltage law. Before that, change all the inductor and the capacitor to impedance first by using the formula for inductor is J omega L, and for the capacitor 1 over J omega C. So basically there are 3 loops, 1, 2 and 3. So this is the equation for number 1, loop number 2 and loop number 3. In order to find the I1, I2, I3, we are going to use Cramer's rule matrices so that we can find the determinant for I1, I2 and I3. So this is the value for I2, I3 and I0. I0 is I2 minus I3 because we are going to find the voltage drop and the current across the resistor number 4. So we are going to find the I0, which is I3 minus I2. So we got the value for I0 first for the step number 1. And then step number 2, remain current source and set V source equal to 0, let them be short circuit. And there are 4 loops because loop number 2 we already got the current, so we just have to find I1, I3 and I4. So we got the I0 for step number 2, 0.46 negative 76.77 degree ampere. So we are going to calculate the I0 total by adding the I0 1, which is 6.690969, negative 174.1057 degree, plus the I0 for step number 2, and then we got the I0 total. And then to find the V node, we have to find we are going to use Ohm's law, which is V equal to IR. So we got the I total, which is 6.647, and then R4 is 2 ohm, and then by using the V equal to IR, we got the voltage node across the resistor.